do have a choice of what we do today, but I got a couple of questions first so we can choose the right thing, if that's okay. Uh, Kim, do you have a preference, or are you gonna let can just go with my gut here?
So the only thing I was telling the students is the last time you taught, you had this graphic of the arrow of AI going straight up, which was so cool. So as long as you can continue with something like that, I'm a happy camper. Yeah. If
Okay,
you
good.
changed entirely and now have a big thumbs down or something, that will be deeply disappointing. Yeah.
Well, it'll be a surprise then. Who knows what my thinking hasn't changed that much. It'll take a year. I'm actually taking a year of giving less talks and doing more talking, so I can maybe so I should change my arrow, but you get my thinking as of last year, not my thinking as of this year. So
Okay.
that's maybe in your favor. Um, okay, so that sounds good. Then maybe we've got a couple of options more than I thought. But hey, folks in the class, what have you learned so far about AI? Like, oh, maybe if each you can say like what your background is, give me a little bit of insight into what you're studying and what your interest is and why you're in the course, and then and maybe just one thing that you've already taken away from the AI lectures so far. That'd be really awesome. Um, yeah.
Ruben?
Yeah, I'll go for it.
Okay.
My name's Ruben. I'm a civil engineer. I'm doing my master's in data science, and yeah, I'm just curious about a lot of things. AI, piqued my curiosity when I first started playing with ChatGPT and turned things into Dr. Seuss poems. Thought that was pretty cool. Um, yeah, looks
And
like
what have
James.
you
Yeah,
Yeah, just
yeah.
before James goes, what's one thing that you've already sort of taken away, or one topic you've already covered in the AI content in the course so far? Just so I'm not duplicating anything you've already done.
Yeah, I think we've kind of gone through just like the overall um, like we had a couple lectures about like neural networks and just like an overall how they work. So like maybe a foundation, a rudimentary foundation on the LLM and AI, and that AI is not just LLMs, but there's models, right?
Good.
Yeah.
Okay, awesome. Good. So we covered that as like AI is more than LLMs. I'm glad we're there. Okay, James, how about you?
My name is James. I am a second year undergrad student here at U of A. I'm currently studying biochemistry honors with a minor in math. And I joined this class because it was advertised in one of my cell bio classes, but I thought it was interesting because I am hoping to go into medicine or dentistry. And I know that AI will have an effect on that future. So far in the class, what I found interesting is like the diversity of the ways we can use AI. So from like again LLM models, but that's not the only thing to like medicine in space medicine. We learned about that. Maybe using like cooperation with AI to do medicine. Yeah, and using AI to like analyze stuff that humans might be able to do. So like analyzing like cancer cells or radiographs, stuff like that.
Cool.
Mhm.
Okay, neat. Thank you. Maybe you just hand over to Tony's. Are you online and up for
Yeah,
answering?
can you hear me?
Yep.
Yeah.
Awesome. My name's Tony. I'm doing my master's in biomedical engineering, but had a background in neuroscience. And one thing that I found interesting so far, from what we've learned, is just like kind of the ethics of using AI in like a medical context. So like we had a speaker talk about like how much she uses AI for even like tips on like diagnosing stuff and like how to kind of navigate that, where like you have to put in your own opinion, but also um, like pick and choose what's correct.
Cool. Okay, good. This is actually maybe we don't have to choose your own adventure. I think we're starting to emerge into a pattern of what I'd like to talk to you all about today. But Brandon, let's hear from you. I'm just sort of moving across my screen here. One more call for Brandon.
He may be away from his Zoom
Oh,
square.
that's okay. Then Athmaja, how about Athmaja? Oh, I don't think your mic is working. Yeah, okay, no worries. No worries.
Hello, good afternoon. I'm Atmaja. I'm in my second year of neuroscience, and I joined this class because I thought it was really interesting and my friends were in this class. But now that I'm like getting to know more about AI, I am thinking about like the legal aspect when AI fails in medicine, especially in cases of medical malpractice law. So I'm thinking about that. It was like
Cool.
really great to like hear from different people about different perspectives of AI and even in like applications in medicine and everything.
Cool. Cool. I guess, Brandon, we're gonna have to give you a pass, I guess, if your mic isn't working. I'm sorry, but I hope just like send reactions or chat things. If you're like, this is totally going, I didn't want to learn this. I want to learn something different. You can just like put that in and we can see what we can do. Okay, cool. All right, folks. In that case, I think just based on the distribution of sort of content and interest areas that you've just shared and what you've already shared that you've already talked about. Maybe I will do a slide deck. I was gonna be like, do we either do like the full like me asking you questions for an hour and a half, a bit more exhausting for everyone, but really high value, or do I share some slides and give you some more sort of thinking fuel? I think maybe we'll go that route if that's all right. So I'm just going to
Yep.
share. Okay, everyone seems to be okay with that. Um, so I'm going to share a screen and I'm going to share sound, which is always terrifying, optimizing for video sharing. So let's see um, if you're getting a slideshow now.
Yep.
Yeah, can you all see? You can see me doing this stuff. I can see all your faces still. Okay, awesome. So then I'd like to share. This is a talk I gave later last year, but I like it for this course in particular because usually when I look at the distribution of content, it'll resonate with some of it. It'll add some new information. It'll sort of extend beyond LLMs and also extend beyond conventional neural network models. And at the same time, it will hopefully give you some thoughts on some of the broader context of AI and how it's being used today. So if that sounds okay, I think we'll go there again, and Kim will be happy because it has the graph that goes up. To
Good.
the moon. Okay, perfect. So we're gonna do this, and I like when I think about the future of AI, because this is how I sort of couch this talk. It's the future of AI. I'm really thinking about the future of us, but the future of us tomorrow. And so to branch into this, I'll try and spin through this pretty quick so we have lots of time for questions and discussion since I hear you're engaged and active. But if you want to jump in at any time, just like raise your hand or just go off mute and chime in if you want to just need to extend. I think we have plenty of buffer time, so don't feel like you can edge in anytime you want for a comment. So when I think about decision making systems, especially us, like I think one thing that we all do, and almost all of the sort of things that we construe as having agency on the planet around us, do a variety of things that roll down to observing, thinking, and acting. Like we think about the way we engage, we use our sensory motor apparatus, we use our bodies to begin to perceive the world around us, to take actions on that world, and start to form elaborate artifacts of cognition to link those things together. And something really cool happens the minute that we start to extend ourselves by way of something like a tool. This is something that was really accentuated by DC Engelbart, the inventor of the computer mouse, in his grand demo. But there's been some recent neuroscience evidence as well, which I think is quite compelling, which is showing exactly how our brain, our cortical material starts to shrink wrap around the tools we use. I pick up my cell phone, or I pick up the remote, or I pick up like a whiteboard marker, and my brain is already starting to integrate that artifact into my neural representations. My brain's already shrink wrapping around the things I'm using, and by way of doing that, I extend myself out into the world. The minute I pick up this whiteboard marker and try to poke the camera with it, I'm extending myself into the world around me by way of my tools. And further, as we start to think about more and more advanced forms of tooling, for instance, I pick up my cell phone now and I play Pokemon Go as I walk across the street and nearly get hit by a bus, which I think most of us probably do. We're now not just extending ourselves, but we're extending and amplifying our own cognition. This is something W. Ross Ashby noted very clearly in the 1950s, was that much like physical power, we can amplify our cognitive power by way of our tools. This is a really important point because I think who's familiar with the Internet of Things? Everybody, yay? Internet of Things. Yeah, my smart plugs, my phones. Awesome. Cool. Well, there's this is actually something coined by Megan Niels. I'll say next the next slide, I think. But we can start to begin to think about the Internet of Body Things, the connected Internet of Bodies. Yeah, Megan Neal and an article in Vice from 2014. It's a good art. It's called "The Internet of Bodies is Coming and You Could Get Hacked" or something like that. Excellent article. But it really starts to frame for us, and there's a lot of work by Matt Machin and others that have followed since, that starts to think about how ourselves and our body and our cognition is now becoming more and more tightly coupled to the technology around us, and that we are starting to form this sort of web of computation that it involves the systems that we use, including systems that are now powered by or integrated with AI, and our own thinking machinery and the other thinking machinery of humans around us. This is when we start to think about things like who's at fault and privacy and regulatory terms, the Internet of Bodies and all of literature coming from it. Actually, some of the really interesting work has been published in legal reviews and things. So it's worth following this. But the reason I say all of that is because artificial intelligence really, in my opinion, underpins this new Internet of Bodies, this new way of integrating with technology, leveraging technology, and performing those profound acts of extension and amplification that go from just me poking things with a whiteboard marker all the way through to extending our mind into the world around us. So that's the lens I'm going to take in talking to you today. And the first piece of that really is to explore a little bit more deeply. And I hope this builds on, and hopefully in some places, maybe even contrasts or challenges some of the things you've already heard in the course. But what can AI do today, and what is it really? It's a chatbot. No, kidding. It's not chatbot. Chatbots might be, someday full agents, but what can AI do, and what is it really? And so this is the graph that Kim liked, and I think I don't even think I'm being optimistic at this point, is I think that if we do like the proper sciencey thing here, and we have like two axes and we label our axes, and I arbitrarily label them time and technology, I think we can quite provably see ourselves to be accelerating at a rate that is greater than we have seen before. And I think you can go back and have a look, and lots of people have made different graphs that look like this. And I'm not even talking about Moore's law. I'm just talking about the rate at which we're starting to see a cycle of technology generating change and us generating new technologies. That socio-technical gyre is getting faster and faster as it spirals into the future. And so when we're thinking about that, one thing that, I mean, hotly contested, what is intelligence? What do we mean by the phrase intelligence? For this, I think I would like to go back to John McCarthy, who coined the term artificial intelligence back in the 1950s. And McCarthy says, and this is what you, if I don't know if Rich Sutton had a chance to talk to you this class yet. Kim, did Rich come in and give a talk?
No.
Ah, well, I'm going to put a slide with Rich's face on it so we can go there anyway. But Rich also likes this definition from McCarthy because it's nice and clear, which is that intelligence, yours, mine, machine intelligence, is the computational part of the ability to achieve goals in the world, to achieve something, to pursue something. And what's cool about this is it's not sort of talking too much about the implementation. It's talking about the computational part of achieving goals. So if we then go through to artificial intelligence, following McCarthy's line here, it is the science and engineering of making intelligent machines, especially intelligent computer programs, bolting it together. It's making intelligent machines means making machines that actually exhibit that computational part of the ability to achieve goals in the world. That's really cool because now we can be like really inclusive in Big Tent and be like, oh, well, yeah, do like LMs exhibit some of the like ability to achieve goals in the world? Well, yeah, now sure. Like I can ask Gemini to go out and find me storage lockers or something like that. And it'll like give me a price distribution. I mean, it is exhibiting some of the ability to achieve goals in the world. In this case, my goals, and things like Claude and the computing architectures can start to begin to actively like pursue and generate code and maintain code. So like I feel like this is a great starting point. And if we go to Rich, Rich hasn't been able to come in, unfortunately, but my good friend and colleague Rich Sutton and our recent Turing Award winner has said that in his Turing lectures that he is really firmly of the mind that we are entering what's called the era of experience, an epoch where machines designed minds. He goes into quite a bit of detail in his talk, quite rightly, on the idea that we are entering the era of designed systems as well, the age of design. But we're entering the epoch where machines learn from experience and not just from human data. That we're done juicing the internet, we're done juicing our private data sets to some degree as well, because where we're moving next is to a world where machines learn from their own flow and stream of experience, that fire hose of data that they exhibit as they act, observe, and perform acts of cognition. So I think it's no surprise, like just as we dwell on that, I mean, we can start to think about some of the successes of AI. And these are probably ones like I'm pretty sure most like before chatbots, these were the things that everyone celebrated. I mean, they're like now it's like, oh hey, guess what I did with ChatGPT today, or Quen did this great thing. Yeah, before that, we celebrated other things, and a lot of those were games, right? Like I don't know how many are familiar with things like AlphaGo or with like the like Dota, the any of those like sort of challenge games? No? Yeah? I see some nods. Okay, good. I got a thumbs up. That's awesome. But really, there were like we saw AI beginning to perform human and superhuman level play and everything from like Go and chess and checkers and shogi. Like a lot of that work was done right here at the University of Alberta by folks like Jonathan Schaefer and um, Martin Mueller and others. And I mean the gentleman David Silver who led the team that did AlphaGo was trained by Rich Sutton and Martin here at the university. So that's a really cool sort of thing that we have here at the university is that we are able to um, pursue advanced thinking machines that play games. That's been a long time strength. But in recent years, we've seen systems that have gone on to play more complicated games like diplomacy, like multinational coordination and collusion with imperfect information, games like Stratego, Scotland Yard, where again you can't see all of the information and agents are working as teams, and even games like poker, which are I mean, it's very, very hard to think about the massive search space of a game like poker, no limit Texas Hold'em poker. We've also seen huge successes in games. I mean, AI has now become spectacular, and this slide's already out of date. But I mentioned Dota. There's also StarCraft 2 micro serving units in StarCraft 2, Capture the Flag, Atari. There's now increasingly sophisticated AI agents that can go in and play Minecraft, Gran Turismo systems through pure trial and error learning, able to outrace human esports players at one of the world's best driving simulators. And it's not all just fun and games. Like the exact same methods, especially methods from the field of reinforcement learning, machines that learn through trial and error, have gone on to essentially interact with a wealth of domains in physics and chemistry, including one of my favorite examples is like a system that can learn to operate thousands of times a second to stabilize plasma at the heart of a tokamak fusion reactor, a real fusion reactor thousands of times a second, controlling magnetic fields that control a torus of energy hotter than the heart of the sun. Like that's just mind blowing that we have now AI systems, and I'll come back to this later. Why there's a double edge of why I'm saying this is very very cool. But we now have systems that like the same kind of system that was learning to drive in Gran Turismo, or that was learning to play the game of like play a game of Go, is also able to stabilize plasma in a fusion reactor, and that's bonkers. We see systems now that are being able to fold the very building blocks of life. AlphaFold is one of the Herald is one of the greatest inventions in recent memory. The ability to essentially look at the entire sequence proteome of every protein known to science and find its three-dimensional structure and the way it interacts with other structures. Looking at reconstructing ancient texts in the humanities, being able to probe the broken, burned, and fractured artifacts of our history to try to sort of glean meaning from them. And like we could go on. This is the cool bit about this is that like if we went through everything from climatology to law to art and design, we would see examples of things like weather nowcasting, biodiversity analysis, learned bartering systems. That was actually some of our team, our research team at the DeepMind office here in Edmonton. Fair taxation design, self-driving vehicles. Like I think we now see self-driving vehicles like Waymo rolling out in cities across North America. So we could go and just like spend pretty much this entire time together today talking about any one of these examples. But I want to show this one. I like this example, and I'll hopefully the sound comes through. We'll have a look and see. But this is like when we say, well, what have the chatbots been doing lately?
Okay, it's your turn.
What do you see on the table?
I see some colorful letter tiles on the table.
Now, could you spell me something that could be found in a deck of cards?
Okay, how about the word ace? I can slide the tiles to spell it out.
can you pack me some trail mix?
Certainly. I have packed the trail mix for you.
Hey, can you pack the orange for me?
Of course. I am putting the orange in the lunch bag.
Thank you so much.
Cool. You could all hear that, right? Like you could hear the dialogue
Yes.
interactions. So,
Yep.
so this is like kind of right, and this is already out of date. If you think about like again, I built this slide deck sometime late last year, and we've already seen leapfrog performance in robotic systems. But this is like if you're like, hey, what happens if you chain a chatbot with a sophisticated humanoid robot? You get something like this. We have systems now that are starting to be able to be bolted together, and this is a big point. I'll come back to this in a second, but the fact that what you just saw was readily possible and it's getting easier and easier. When Microsoft first took ChatGPT on a test drive, they took it out for a spin before buying the car, and they showed that they could chain the earlier versions of ChatGPT into like drones, flying drones, robot arms, mobile robots, and have preliminary versions of what you just saw. This was Gemini working with Aptronics in this case. Um, and I told you about Gran Turismo earlier. Gran Turismo was a research breakthrough. It was in the journal Nature, which is a pretty good journal. And now that same sophisticated AI system is rolled out across every single copy of Gran Turismo that's on PlayStations all around the world, with the ability to drive all the different cars and have different levels of difficulty to interact with actual human players. So a research breakthrough became a product. Similarly, we're starting to see AI design of things like aerospike rocket engines. So this is one that was designed by computational AI and actually fired by a group, and I think this was in the UK, yeah, in Sheffield in the UK. We're seeing companies that have promised that they are developing the very first AI generated medicines where the target and the compound were both generated by artificial intelligence. And this one I'm showing you here is from one particular company which has published papers and showing that they're moving into phase 2 randomized clinical trials for this particular heart muscle drug. So this is already, again, they also claim they have a AI scientist in their lab. I haven't verified that claim. I can't say whether or not they have it, but the fact that they're doing end-to-end drug design where the AI is finding the target and also creating the compounds, and that this is actually moving into like in rapidly changing the cycle of drug design and deployment is something that we should take note of. We've seen this is now a wound down project. Actually, one of our professors, Dr. Marlos Machado here at the university, worked on one of the leads on this project. But Loon, having self-driving balloons actually over sub-Saharan Africa to begin to deliver internet across internet voids in various landscapes, and like a whole fleet of balloons that would coordinate, take naps in the upper stratosphere, and try to figure out how to configure themselves to maximize their ability to continue to power themselves while also serving internet in a collective fashion, like real deployed systems. And the reason I showed you all of those and the reason I staged it the way I did is that I think we are seeing a transition. We're at a transition phase which supports my bendy curve that Kim likes. One is that we're starting to see a transition from tools to agents. So we're starting to see agency as a prominent focus, and this is very in line with Rich Sutton's line of thinking. We're starting to see breakthroughs that are becoming product things that used to be something that everyone crowed about and we celebrated in journals like Nature and we wrote a paper and then moved on to the next thing are now like Gran Turismo Sophie being deployed in actual products. And we're seeing a shift from sort of monolithic systems which might make up the solutions to their problems. Remember the whole hallucination chatbot issue, to integration. We're seeing systems like a humanoid robot being integrated with a large language model or a large cross attention model so that they can begin to synthesize a real world stream of experience with that kind of language based understanding of the world to be able to generate complex behaviors that are not hallucinated but in fact integrated. So this is the first part of the talk, is that I just want to say that the cycle of this happening, think about that drug design cycle. It's getting faster and faster and faster. Tools are becoming agentic at a rapid rate. Breakthroughs are becoming products, and systems are now integrating at a spectacular speed, supported by those agents and those productized agents. So that's the first bit of the talk. Does anyone want to jump in and ask a question now, or do you want to keep powering through and then do more discussion at the end? It's up to you folks. If anyone has a question though, I'll let you I'll pause right now and let you chime in. They're like, nah, we're all good. We're doing homework for another course while you talk, Patrick. It's cool. It's cool. All right, that's all good. Let's go on then. I'll go on to the next piece of this, which is like if I have told you about all of those tools, and if you believed me at the beginning when I said that we in fact do use tools to extend ourselves into the world around us to change the way we represent and think about and act upon that world, and then to, of course, amplify our capacity, then every one of those tools I just showed you, those breakthroughs that have become tools and products, should have increasing impact. And so I want to go into this a little bit. The neuroscientists in the crowd will probably like this a little bit more as well. But to think about AI and how it's starting to interact with you in some of the closest ways possible. And I think one of the ways that we can see, and this is just one example, Neuralink is just one of many companies now that are looking at ways to couple thinking machines into the sort of the wetware of the human body. In this case, Neuralink is looking at direct cortical implants, pop out a piece of skull, you sew in some flexible electrodes directly into the brain tissue while dodging all of the blood vessels. And then you seal things back up with little glue and a USB wireless connector, USB-C and a wireless connector. Anyway, we're starting to see people trying to and successfully achieving direct integrations with the tissue of the human body and the decision-making apparatus of the human body. And for Neuralink's case, again, they've shown that people that cannot move their bodies are able to play like elite esports, that they're able to begin to generate speech. They're looking at putting vision back into the brain, and they're not the only one. There's other companies like Paradromics, Brown University, I think, is working with Intel. I think it was Intel. I hope I'm not misstating it, to like bridge gaps in the spinal cord and actually create like flexible AI powered connections across a damaged part of a human spinal cord. The list goes on. So I think we're seeing first the capacity to begin to read and write from the very root of human decision making, or at least the neural substrate of our decision making. So that's one big change, which has been powered in some part by AI, which is also enabling the interaction of us with AI systems. For instance, just even thinking about language generation, someone with a brain implant being able to speak in the voice they would have had before they lost the ability to speak. That is a very powerful thing that is supported by AI, and they extend themselves through the use of advanced computing technology based on machine learning and similar methods. Um, we're starting to see new ways of changing the interaction with the human body. I'm showing you here some examples of dermal electronics. We're now seeing like actual computing technology that can be wafer thin and adhered to the surface of the human body, to the skin, such that it can read, in some cases, write biosignals and be able to essentially extend ourselves by way of monolayers of computation that is laminated, in some cases very, very durably onto the human skin, in some cases in a way that just melts away after use. Um, the area that I like to work in, this is near and dear to my heart, is bionic body parts, artificial limbs. For instance, a gentleman named Piotr showing off one of his forearm prostheses, which is many of these now are very much AI enabled systems. They use machine learning to interpret signals flowing from the human body and map it to the control of mechatronic parts. In this case, Piotr's showing how he can voluntarily either gently close around objects or deform the objects. Don't worry, he's not going to smash the glass and like throw it over his shoulder or something. He's able to pilot his robotic device to be able to, again, very naturally and flexibly interact with the environment around him as he's engaging with different objects. These are durable systems, but they're also systems that have a lot more customization and a lot more dexterity than they used to. We're finding new ways. This is some actual work that is being done right here in Edmonton. We're one of the only centers in the world to be doing bone anchoring. There's only a handful across the world that are doing both upper and lower limb bone anchoring surgeries, connecting robotic body parts directly to the skeleton of the human body. This is David. He's one of the individuals that had a surgery here at the University of Alberta Hospital and post surgical rehab at the Glenrose Hospital. But you can see he's actually got a titanium shunt that goes directly into his bone. You can see him wiggling it there. And then he's able to attach his computer controlled robotic leg directly to his skeleton, just as if you were almost like you were connecting a bike seat to the post of a bicycle. Now he's able to stand up and move. So we're finding new and sophisticated ways to be able to attach humans to the assistive technology, as opposed to like this, where he's trying to put his leg in a socket. This is prior to surgical intervention. There we go. And I'll show you some work as well. This is from our lab, the Bionic Limbs for Improved Natural Control Laboratory. 2024 fall, we participated in the Cybathlon, essentially the Rehabilitation Technology Olympics. This is our pilot, Chris Nielsen. He's someone who's lost his limb above the elbow, and he's piloting a custom biomechatronic device from our lab, an ultralight competition grade limb system that was supported actually by the Glen Rose Hospital Foundation. And Chris is here doing an incredibly sophisticated, challenging task, which is a hot wire task. He's trying to coordinate his bionic elbow, wrist, and hand such that he can navigate this ring around this metal without actually touching it and try to do it as fast as possible. And so this is a combination of machine learning technology, conventional control technologies, and a lot of training and hard work and skill on the part of Chris to be able to perform this sophisticated. Like we actually use this in the lab. We have like a speed challenge rating thing in the lab, and it's not a straightforward task to be able to do this at speed with also like that, like not accidentally touching the metal and failing the task. So at this point, you can see we're all like nail biting. This is a global competition, and the announcers were speaking. And he's like, "I can hear you guys speak." I can see him. It's like, "You can hear me." And he managed to do it. So that's an example of Chris successfully completing one of the challenge tasks. And he was one of the only people in this particular branch of the competition that was able to perform that task. And he was top 2 in the world for people without a biological elbow in the upper limb arm competition. You can see these are some of the other teams. He actually he scored higher than all of Spain, all the teams from Spain. Okay, so I showed you all of that because we're moving to an interesting space, and this is where, like, if we think about our relationship to technology, our relationship to the tools that surround us. Like, think of those bionic limbs, Chris piloting in a skillful way, that robotic system with multiple controllable joints, with multiple ways. Like, he was sending information from the muscle of his residual limb into a commercial machine learning controller. We also had our own machine learning gear running on board. He had conventional control algorithms as well, controlling different parts of the system. Chris was extending himself out into the world by way of a sophisticated piece of technology. And in this case, machine learning played a fundamental part of the glue that connected Chris to that technology and allowed him to excel and to use his skill and his innate abilities and his learned abilities to be able to succeed in a challenge task like that. And I'll just go back one more because I show here on the slide, like, it's not just us communicating with a simple tool. I think we all use our phones and things like this to interact with a much wider tool set. And so all of those tools that I showed you before, all of those technologies and like the amazing, wow, AI can do blah in the first part of this, everything from weather nowcasting to stabilizing like ultra hot plasma. These are things that are now within reach of our actual computing machinery with our bodies. The ability to, by way of and through the use of machine intelligence, be able to extend ourselves out, not just into a robotic limb or even into a, like, my car will self-drive for me on divided highways and even some single lane highways. That's kind of amazing. But it goes beyond that. It's like extending ourselves out into that vast tool chain, embodying some of those vast swaths of tooling, and also being able to amplify ourselves by way of all the tools we talked about in part 1. So when I think about part 1 and part 2, and if you put them together, I hope you're seeing a view of what us tomorrow looks like. And it's a very different view on us. And it's a view that it changes much more rapidly than we ever have changed before. And that's part of my supporting evidence for why I showed the curve going up. The make Kim happy curve goes up. You can be a really great corporate CEO or board of directors, Kim. You'd be like, curve goes up. Good. Yes. Yeah. Share profits. Humanity, futurism. Okay. So now, okay, why does that matter? So if you believe me that AI is capable of many things, and that hopefully we diversified your view into what AI is capable of in that first part of the talk, and you also believe me that we are starting to more and more tightly incorporate technology into our action, perception, and cognition, and including access to those tools, then here's my impact assessment, or at least some of my actionable forecast that I hope we can all ruminate on as we start to move forward into this very strange new world we're walking into. And first, I'll show you one more video, though.
Busy, but you're on your way now. How can I make your drive better, Josh? And do you need anything from me, like music suggestions?
One of the things I find pretty fascinating about Astro is that it can remember what we talked about before.
Wait. Do you remember what we made with celery last time?
Yes, we added a bit of ginger to it last time, didn't we?
How much ginger do you think we should use from this?
For 8 cups of juice, a 1-inch piece of that ginger should do the trick.
I don't have a ruler on me. Do you think this is about an inch?
Yes, that looks like about an inch to me.
Here we go.
Okay. So that, like, when I first showed this, what was it, 4 or 5 months ago? I was like, oh wow, like this was Google's project, Google DeepMind's project Astra. It was the essentially, what if the agent, what if your favorite chatbot was actually living in your stream of experience? What if it was seeing what you see to some degree, and you could interact with it, and it could have persistent memories? And that was like a prototype when they were just spinning out Astra as a few case examples. I saw this over the years as it was starting to be built and now as it's being deployed. But now, like, I do this all the time now on my phone. Since, like, in the small gap since I first made these slides, and the fact that I can now, like, I hold up all the time, like, hey, yo, Gemini. Oh, wait, I can't say that now. It'll probably launch it. But hey, AI friend, Kate, like, what's this light bulb? I got it my kid's lava lamp. Like, can you tell me what kind of bulb this is? And it's like, I don't know, it might be this. I'm like, okay, well, let's hold up. It's in my hand here. Or, like, I walk around, like, where should I be, like, slicing this thing, or how should I put this in a barbecue? I do this all the time now, and it was just a small gap from when we might imagine an agent having a persistent memory, but really our chatbots forgot every single thing the minute we talked to them, and they couldn't even see. We had to type to them, to the point now where the agents I interact with know that I, in fact, am a roboticist. They're like, yeah, well, you could try to fix your Christmas lights this way. Or since you're actually a trained roboticist and you know how to do things like do it yourself, here's a much easier way that would other people find hard, but I'm going to give you a solution path and the components to do a better way for fixing your lights that might be more accessible to you. We now have agents that are starting to know us, know what we're capable of, and start to interact with us in ways they didn't before. And so this is one of my first forecasts, which I think we're already starting to see come true. When I even think of, like, our local parent society, and, like, they're using personalized, specialized agents to help them navigate being like a nonprofit looking to fundraise for schools. Like, how do we see agents interacting? We see them, I think, in the next year to years being very personal and very personalized in their deployments, in their memories, and having them touch every sector. I do think that we're seeing agents move towards ubiquity in our community, in careers for sure, and also in compliance, how we comply with regulations, and how us as individuals and also as organizations comply with laws and stay in track and in target with the laws. A part of this, and this is actually, I realize, I think this is no longer in the AI's AI UA's AI use framework, but it was a nice line from it. And now there's a new revised AI accountability framework. If you haven't read AI's, like, the AI framework at the University of Alberta, I recommend it. Like, how is it fair and safe and reasonable and responsible to use AI in your campus interactions? Totally read that. I really like this bit, which again, I think has been modified in tone, but it really echoes what's being put out in things like the UNESCO 2024 competencies on AI, which is that it's the responsibility of the individual to have a base level of AI literacy and safety to safely and appropriately use AI. Like, this is like in my lab, we're really, like, pretty responsible about how we use our tools. We have a drill press. We don't just let anyone use the drill press. You have to be trained at using the drill press. You are supposed to be using it safely. You put on the safety glasses. You put on all your proper PPE when you're using rotating machinery to, like, bore a small hole in a piece of plastic or aluminum. And so the same thing is true for AI. And I think this is something that we are seeing now across industry, academia, personal life, that people are expected to be literate and accountable for their use of AI. And so this is something that I think is actionable, is that we can all work hard to increase our individual literacy and our accountability, so that, like, yeah, we're trained on how to use our drill press or our soldering iron as we go out and do that. So again, please read the U of A's framework on appropriate AI use. Another trend that I think is very important is the trends we're seeing in access and equity. And this, I like showing a pair of graphs here, but this particular graph, I think, is no surprise to most of you in general, which is that it also echoes, this is performance of top AI models as of, like, mid 2024, late 2024. So this is already out of date. Again, we can go back to Epoch AI and get a new one, but you get this older graph because I didn't update my slide. But it also holds that we're seeing a rapid change in the accuracy, the capabilities, and the general versatility of the large, massive AI models. I say massive because the training compute and training energy of some of these is spectacular. What's interesting, and I think this graph still holds, is that the closed proprietary models and the open open source, open access models are beginning to see a lot of consistency between them. The open models have caught up to some of the closed models, and in some cases, we're seeing the open source models jump ahead of the closed source models. So, takes a lot of effort to create AI models. A lot of these are like chatbots. We can't even say chatbots now. These are multimodal models that are able to integrate tooling and web search and different modalities. But we're seeing that the open and closed models are both increasing capacity, but that they're both gaining um, utility. And then if we look at the cost to use them, this was like we saw a big sort of transformation happen, especially after that the DeepSeek moment when it turned out you could train things and get them very functional and even show reasoning with a lot less compute. But people have been working very, very hard to figure out how to do inference, to use the AI systems that we built in a less energy and less cost demanding way. And I like this graph because it's getting to the point where we can run very sophisticated AI systems on our personal computing devices. You can like run some of the gear on like little tiny Arduinos you can get for $33, and you can have like language models running on Arduino. I have one upstairs. So like this thing comes with like speech recognition baked in to like again a $30 like Arduino Nano 33 or something. It's like tiny. It's like, the size of the tip of my thumb, and it can be using sophisticated models that previously would have been just shocking in terms of their resource hungriness. We're seeing inference costs drop. So I like this because here's one trend I'd like. It's my optimistic trend. They keep me around. Kim keeps me coming probably because I'm an optimist. I'm the team optimist here. But I feel like there's actually something really neat here. We're seeing the capacity, like if people are working together or expending massive effort and then sharing very large capable AI systems, AI models that are accessible to anyone in the public, and the cost to deploy those things are going down. This suggests to me that there is a world, and there's a world that we could all aspire to, and probably even achieve, where AI is in fact fits the definition of a public good. It's non-excludable and non-depletable. That my use of it does not prevent you from using the system, and that all of us have relatively equal access to the same kind of capacity of at least baseline models that we can use in living our daily life. This is a really optimistic world if that is actually comes to pass, and I think the trends are not dissuading me of this. Like it's sort of the counterpoint to the AI systems are only going to be available to the megacorps, and we're going to have to lease our offboard cognition from the megacorps. I think this is another complementary view to that. And it goes back to one of my other. I like the quotes from the 1950s and 1960s, as you may have seen already. But I like this particular quote because if we put together part one, part two, and sort of part three of this short talk, then we can reflect on this quote from J.C.R. Licklider in 1960. And I'm going to read it directly, which is that the hope is that in not too many years, human brains and computing machines will be coupled together very tightly, and the resulting partnership will think as no human brain has ever thought and process data in a way not approached by the information handling machines we know of today. I think Licklider's speculation or strong conviction from the 1960s is in fact now a world that we are living in. And so, like when I think about you tomorrow, you will be and actually already are an ecosystem of increasingly diverse and vast elements, and this is going to influence and already is influencing the way we act, observe, and think, like we mentioned in the first slides. But all the other things you do, study, learn, forecast, build, imagine, articulate, design, deploy, the way we do these things is increasingly becoming a process that involves, as I note here, a vast ecosystem of diverse elements. There's actually a really good quote. I'm just gonna I will finish actually with it. It's not in my slides, but I want to share it. And that like because this progression is ancient, it is expected. This is something that like hey, mitochondria and cells got along really well early on, and they started to build together for a very very long time. But it is in fact an ancient expected progression. You're already more than the sum of your parts, and I as much as I want to dwell on this, like I do think the cycle is scary. And so I'm just gonna actually pull up. I have it on my I'm gonna pull up on my phone because I took a picture. There was an excellent book which I'd like to recommend to all of you um, that we read recently for a reading group I'm involved with, but it was called Unfinished, and it's a book about AI in music composition. Because when we're thinking about how technology like AI is changing the way that we do the things that we do, the way that we live our lives, the way that we carry out the acts that we consider to add value to civilization, often we see AI as starting to impinge upon that. Unfinished is it's Lucas Cantor Santiago, who is a very famous composer who, in fact, took on the very sort of, I would say, is a very ambitious contract to use AI to finish Schubert's Unfinished Eighth Symphony. And this book
Cool.
is about that and around that. It's a lovely discussion of what it means to be a composer and how music has always been coupled to technology and how the two have never changed without each other. And how maybe the golden disc we sent out on Voyager would be read as aliens as like rubbish because it's actually like our way of tuning instruments was a sort of satisficing and it's not actually as mathematically pure as we might like. Anyway, so the reason I'm saying all this is that in this cycle. I'm showing again the increasing cycle of breakthrough to product and artifact to straight through to agency, like tools, the way that tools are now becoming more agentic and the way that our systems are integrating parts in a faster and faster way. I'm going to read directly from this is from the section Allegro from the book Unfinished by Santiago, and uh, it he writes that well, at first glance, it feels like it will that I paraphrase AI and technology will threaten my job as a composer, or even threaten all of human creativity. Goes on to say, if what I sell is the product, then anything that makes a similar product through more efficient process is competition. But what I sell is the culmination of a process I've developed over half a lifetime, and it's unique to me. Let's say that the product I sell is a recorded piece of music. What gives this product value is that it is the result of a chain of ideas I formed over a long period of time. And so I like this quote. I've been thinking a lot about this, and I wanted to sort of finish today and then go into discussion on this particular thought, which is that when we're faced with this cycle, when we're faced with the bend of the curve, what do we invest in? What is a valuable thing that we can invest in to create future value? And one of those things is us, in our own understanding. There's a focus, I think, in a lot of our professions and our fields on product, on outputs. And I think process is something that is now increasingly important for all of us to think on and to cultivate us within a process. Because I agree here. If the product is the thing that we are all focused on, then product is something that might be much more competitively built by something else. But if it's a process which is unique to us and forged over a long period of time, and that's where the value, if that's where we hold the value and we see the value and we seek the value, then we engage with the technology in a very different way, as Santiago is noting in this book Unfinished. So that's my pitch to you, which isn't a slide; it's a new addition to this particular sort of semi talk. But I would encourage you all to think about the process and not just the product, and also to read the book Unfinished. It's an excellent book, and I highly recommend it.
Wow.
Anyway, thank you. And let's have some questions.
Very cool. Yeah, maybe this is not fair, Patrick, but I'm going to ask it anyway. So, what the students here wouldn't know about you is that you're a published award-winning poet too, and so let me ask you about whether AI has completely overwhelmed you as a poet. I would think not. The reason I would think not is you haven't been doing that much poetry in recent years. So if
Calling me
you
out,
were to
Tim.
challenge,
Oh,
you were to challenge AI to do something, create a poem in Patrick Pilarski's style, it wouldn't be as good as you yourself would be able to write because they don't have their training set doesn't have a lot of your poetry and stuff, right? So there are still realms in which even if the overall IQ of the AIs around you is much higher than yours, there are things that you can do much, much better than AI. But as soon as we tried that, then AI would get wind of this. And then a few years later, they would be better at Patrick Pilarski poetry than the man himself. So am I right about that? Or what do you think?
I mean, I, as you know as well as I do, that the framing of better in poetry is
Yeah,
already fraught with disaster. It's a very thin
sure.
piece of ice over a very deep piece
It
of
is.
cold water.
Uh,
That like so. I think that there's enough of my published work. There's probably more published units of poetry than units of scientific output. Despite professoring's hard, so I mean, I haven't been doing as much poetry. I admit that. Um, I've actually been pouring my craft into other
Yeah.
things, in part because I don't have to share it with other human beings. But there's enough out there that I can go in any library, can read the things I've published in like the Fiddlehead and like CV2 or whatever it is. That it can go and like read those. They're in libraries. Systems can access libraries. I mean, you could probably have a probably even better than what I might create if you were to put me on the spot right now. You might be able to get an output like that. But I think it goes back again to the process. Where I am what right now and what has changed in my mind since the last time I wrote something is going to be different. It's unique to my trajectory. This is like you have an old violin acquiring scratches over generations, passed down from family member to family member.
Yeah.
You can't fake the scratches. And you can argue whether or not that makes it more or less valuable, but that trajectory, that process, that's why I really like the book Unfinished and why I really like that particular quote from Santiago, is that the trajectory itself is what informs what is created. And that is what people are going to be potentially placing their value in. So whether or not the poem itself moved you or was good or changed things, this is very true. And like in the music, I really learned a lot from reading that book because I'm also someone who plays music. Like I've picked up
Yeah.
the banjo for the last few years and I used to play in a punk band. Like, I mean,
Cool.
I,
Yeah.
I really like music, and technology, of course, informs how we do that. And we just express ourselves differently and it shapes how we express ourselves. And music might move you differently than it moves me. Me reading my own poem might be very different than in how it changes my internal operation than it does for any one of you. And I think the same can be said for something created by solely by a machine. Like imagine you have a machine that is just sitting out there. It's not even reading and digesting and synthesizing poetic patterns, but it's truly trying to come up with something from scratch, which I'm not saying is out of reach. Like I don't think you have to juice the internet and all literature on the internet to get a super powerful machine which can create creative artifacts which are going to rival those of the other like the other people in the
Right.
world that have to be made of human stuff. You don't need to juice literature to get literature. I think there's other ways to get there, and we're seeing machines that are able to get there faster in some cases than by distilling what they find on the internet and all the libraries.
Right.
So
So,
with that in mind, I'm just saying is
yeah.
that how we engage with a creative artifact and how it moves us or changes us and changes our thinking is going to be different. The what changes in you on reflecting and engaging with an artifact that I have created through my own means or whether a machine has created will be different, and there's going to be different value from them. We'll extract different value, and the ability to have conversations with the entire there's a great article actually, which I don't know if it was on what is the fate of the like what's the future of the humanities in the era of AI. An
Mhm.
excellent article. It was in the New Yorker. I think it was New Yorker. Yeah, I think it was almost certainly. Let me just double check my citations here for y'all, so I don't betray your trust and give you a bad citation. That would make me a bad professor. I'm just gonna double check. Um, you think? Yeah, no, I'm serious about that. Okay. Yeah, there we go. It was indeed. Yeah, the New Yorker. So the New Yorker weekend essay from April 26, 2025. Will the humanities survive artificial intelligence? Really great article. You can go find it on the internet right now. It was by, I'll just say the author as well, because that matters, Graham Burnett. And what was cool about this is that as like a professor who works in philosophy and the humanities, the author was saying, never before have we had the ability to converse with a large facet of the entire human archive. People have tried to do this by reading books and thinking in conversations with themselves about what they've read, but now we can actually converse with the archive. This is true for the artistic archive as well. And what we might engage with within that medley of human and machine synthesized creativity is going to allow us to explore ourselves in ways we've never explored ourselves before. We'll be able to change our mind in different ways. And so this long way to answer your question was like, I actually doesn't matter to me if a poetry bot could out poetry me because it
Right.
probably will. But where is like, especially for poets, where is the ability for us to add value? Poets and philosophers, well, part of it is by adding new ways for people to engage with the human archive, the human like corpus of knowledge and idea, the leaves and branches of the tree of knowledge and the tree of inspiration. And so I think that's something that it sort of redirects the question and says that it doesn't actually matter if the poetry is better or worse because we can't judge that anyway, but it gives us different avenues to engage with our own civilization and ourselves. And if we truly believe in growing ourselves, if you believe what I said, that process investing in oneself is now the important thing to do, then this is an even more, we need more of this, not less of this. That's my
Yeah.
soapbox. Okay, sorry folks. That was Kim got me going. That's his fault. It's my soapbox.
Okay, so let me tell you something else. I have never submitted a late breaking abstract to any meeting, but I'm doing it now. Now, where did that come from? So on January 1st, 2026, there was this video about the idea that polymathy, being good or a genius at many different things, can be learned, can be taught. That all you have to do is so behave during the day the way Michelangelo or Steve Jobs or Ben Franklin did. Do the things they used to do, and you yourself can be as creative and impactful. It sounds crazy, right? But the thing is that a book was written about that in 1998. Nobody paid much attention, but this video is really good, giving all the evidence that polymathy can be taught. But then something else happened, which is even better, that the idea is that how do you figure out where to start with that? If you're going to say, well, let's take a person and have them behave like Leonardo and so on, and see if they can create stuff, right? But wouldn't the genetic similarity to Leonardo help you if the person was like closely related? And so they found on January 8th, there was an article in a very good journal saying there's all this stuff that Leonardo handled, and it has DNA with these characteristics. And we think the only outcome could be this is his DNA. So anyway, so what do you think about this? Do the students here, am I misleading them by even telling them about this? Did they all lose the, genetic lottery? They don't have the genes to be a polymath, so they shouldn't even try? Or do you think they all should try?
I'm just gonna grab my copy of Norman Doidge's The Brain That Changed Itself, and we'll come back here in like 30 seconds because like our brains are intricate, detailed decision-making organs, which are highly flexible. I mean, I wish I was like good at single mathy. My math, irrespective of the board behind math on it, like I'm not that great at math. I would love to be great at multiple maths. That would be amazing. But no, like our brains are incredibly changeable. Our brains change with the technology. Our brains are like the simple act of having a piece of paper that we can write on is offboarding our cognition. Of course you could, like of course you can extend yourselves. Like we can go back like many years, and people, again, I already brought up like people like Ashby and like Norbert Wiener and Licklider and Engelbart are my usual favorites, but we could keep going and like rattling off other examples. That of course you can extend your cognition. Of course you can use the tools and technologies around you. I think this is one of the actual enablers that we overlook in things like the wave of the chat GPTization of things, that in education, that it's like it actually allows people with different styles of learning and different ways of engaging with content to be able to potentially leverage that content and multiply their ability to interact with topics of all different kinds. So I don't yeah, if you're pinning on DNA, you're gonna be changing that. You'll be 3D printing yourself a DNA modifier tomorrow. Like that's I don't think I don't think it's gonna help though. I don't.
Yeah.
All right, I want to hear from some of the other folks.
Yeah,
Other folks in the class.
We need to hear from students at this point. Yeah, Ruben.
I didn't quite understand the process comment. Is that just like the like AI is going to be able to create everything, perhaps at least as good as us or maybe better? So we need to invest in ourselves. Is that the kind of the direction that you were going with that, or if you could elaborate a little more?
Yeah, and like I mean, I'll just say it differently. It's the like when I am working with folks to figure out what they're trying to do with their life. Hey, after I graduate, what do I, or before I graduate, what should I be focusing on? One of the things is to be able to craft a unique experiential trajectory for yourself. And like there's a very human element to pursuing a craft, to pursuing training, which is going to be situated in your immediate real world flow of experience. You're going in the way that you move through life, the way that you engage with your graduate program or your undergraduate program or your job. And that is going to create uniqueness. And if we believe folks like Santiago that this has already been what we've put our value in over potentially thousands of years, then that uniqueness of trajectory is the thing that will lend value to the work that you do. The creation of the product is actually only a part of it, but what people will be looking for when they're engaging with you and your contribution to civilization are the way that the product is shaped by the process and by your unique trajectory. And that combination is in fact the thing that is adding value to the world, not just the product, but the product, I don't know, reverse dot product. What's the again? I wish I was good at single math. Anyway, the like looking at the like the opposite of the inverse product or something. Anyway, you take two vectors and you get a matrix out. We like the fact that you are smashing together your product, like the product plus your unique expertise, trajectory, and process, and those two things which have been cultivated together jointly, thus over a vast period of time, that adds the value in part because time is the thing that no matter how many simulations you run, the time is a thing that we do not have access to automate away. And time with respect to the natural ebb and flow of experience. Because I mean, you could say, well, I'm going to simulate everything, but no, you have an experiential environment that you have been within, and that's also been shaped by the time. That is a unique thing which could either be ignored, which it sometimes is. Like you can see like the industrialization of things where it's like it doesn't matter if this widget maker has like it came from a farm or they came from a Victorian era household or if they actually were an alien. Doesn't matter. They're going to be making widgets and I want the widgets all to look the same. And so you might be like, okay, that was all about product and not about process. And I think in the arts though, it's often been a lot about like there's product as well. You're the bard going from end to end to end, like following Gerald de Rivia around and like singing songs about him. And you're like, yeah, that song's going to make you a lot of money. But often though, it is actually in the arts, especially that the process, like Kim and I, our conversation earlier about poetry, that process is really important. It's something that also respects what has happened in the history of things. So I think this is a time of those times where if it's all about the industrial revolution of making widgets, then maybe that's going to be it'll be hard to add value in a very tangible way if we're thinking about that sort of that union of process and product. That's something very special. And anyway, that's what I've been thinking. That's like what I've been thinking about this year. That's different than last year. It's something. Yeah, I it comes up in my conversations. I went for a lunch conversation yesterday, and this is where the conversation steered. It's not just, I think, me steering it there, but I feel like this is a question that is immediate and relevant to us to all ponder.
Plus, I think in some sense, there will be whole new worlds that like spheres that we don't spend any time thinking about now that we'll suddenly realize, holy smokes, in addition to all the things I've been thinking about, there's also this that I never thought about before. I don't know what that thing is, but there will be one of the things that AI will bring us. Some of their unique creations will, enlarge the world as we know it, and there will be more untraveled, unexperienced stuff. Yeah.
Ruben, what were you going to say? You were going to chime in.
Yeah.
Yeah, I think like through the Industrial Revolution, we figured out how to make things really cheaply, and it was amazing that we could have computers and forks but there's something charming about handmade things now, and I think like that we're going back to like handmade things. Like there's something about like a belt or a boot that's handmade, and I think it's something similar for art, for AI art, that like there's like we used to, the Industrial Revolution changed how we made things. The AI revolution, among other things, is going to change how we make art. And it's like if people want amazing art on their wall, that's great. But there's something charming about the story behind the art and the process for how the artist created it.
And the provenance, exactly. It's funny you say this because I'm like thinking about my like I have to profess stuff and I have to study things so I can do more. I know there's some like contract with the university says I have to profess stuff, but I have to do a lot of research. And the kind of research I'm doing is changing. I'm not just trying to make the next best algorithm to interact with like bionic devices. A lot of our team's work now has focused on qualitative methodologies to be able to investigate how people engage with adaptive technologies. We're starting to think about the individual interaction with their environment, their subjective experience of reality when they are pursuing that reality along with a piece of technology which is adapting to them and with them. Like what I study and how I study it is also pivoted towards the sort of the very much single subject, more qualitative, more subjective investigation, as opposed to the like, can I make an objectively 5% better algorithm? Uh, I probably won't need to. I'm going to be very honest. Like that is not the research the world needs to do right now, at least in my area. I think so there's going to be some extra innovation there, but a lot of where the change is going to happen is when we start to think harder about those unique journeys and those unique trajectories, the artisanal nature of ourselves. It's like handcrafted human lifing is a very important thing. Like, I mean, what was I doing? Like, in terms of building things, what was I doing 2 days ago? I was in the garage blacksmithing out a new ice chipper because my cul-de-sac is completely flooded in ice, and I was like, cool. I'm gonna go out there and like hand make, lovingly craft this piece of like tool steel until it's the ideal ice chipper I've always dreamed of. And there's like. It's unique to me. It's not something I would mass produce. It's not something I could mass produce, but it has a qualia to it and its interaction with me personally and specifically, which is
Mm.
unique. And there's something about the one size fits all, which has gone through waves of like, hey, everyone could make like cake out of a can. That was really like that was a sign of status at a certain period of history. And then it became a whoa, but everyone has the same cake. That's kind of boring. Let's learn how to cook cakes again really, really well. Like we get this ebb and flow of personalization and crafting things to individuals. And I think this is a time for crafting art and science and technology to individuals, whether it's that's the study of that individual or whether it's the interaction with the individual. Yeah.
Yeah, that's interesting. That's a good point. That like the individual matters a lot more, and like that qualitative research from an individual. That's an interesting point. And then, yeah, whether it's like 3D printing or whatever, that like individual, you can make individual tools for your problem
Yep.
or for your
Yeah.
life. Yeah,
It's
cool.
it's it's wild, and that's like it's a different innovation space, right? As Kim was
Hmm.
saying, worlds, and we're creating a different world for ourselves, and
Yep.
that means maybe that the customization piece is different than it has been before, or it's different again in a different way.
Hmm.
Anyone else want to chime in? We have about 10 minutes left, I think, if I'm
Yep.
tracking time right. Anyone else? Brandon says, AI didn't fix my mic for me, and I'm very disappointed. The future is not here. Your curve is broken, Patrick. Um,
Yeah, a lot of those things, life will get simpler as well as more complex. You could imagine that you could repurpose some other component of his laptop, make it work as a mic. And it's not something we can do today, but just making those speakers work as a mic when your mic fails will be a thing probably in the future. So instantly, when this happens, you can fix it
it
remote.
probably is already a thing. I just didn't try it. I was like gonna because we'd be running local models now. I could have just like checked on local models, like, hey, I'm giving you rag access to my like my peripherals and things. Can you just like make stuff happen for me? Can you mute? You know what I mean? Yeah. Yeah.
Yeah.
That's cool. All right. Is there any other last reflections, comments? No, everyone's good. Atmajai, you're good.
So, like, this very much satisfies me. Is it too out there for you, the students? Does it seem too extreme? Or is it what you were hoping to get from the course? Yeah.
They're
Uh,
fire Pilarski. No, this is what we wanted all. They wanted to tell us how to use chatbots to make money and gain influence with our friends. Like this wasn't what I signed up for.
right. Yeah. No, I think that this has been a very successful session. Let me just tell you a little bit, Patrick, what we're going to do on Thursday. You're probably aware that the Kipnis Institute now ECHA has been renamed and so on. They're looking for the inaugural director, and I'm applying. And one of the arguments is that I've surrounded myself with young people the past 53 years. Youth is infectious. So therefore, I am, by definition, the youngest applicant because of that.
That's like solid elder vampire sort of thinking there. Keep me like, ah, yes, by like draining the souls of all of the young people I've been around, I'm immortal and youthful for all time. I'm 1,000 years old, but I look like I'm 12. Yeah, no, that's vampire thinking there. I don't know if that tracks. Also, Kim, why would you do this to yourself? To lead something large? That's um.
No, I
Anyway, that's
think it
we're
would
on record.
be
Sorry, we're recording. I retract that question.
would be the greatest fun. Yeah. Yeah. But anyway, so like think about this group of students. There are actually 8 students and 2 TAs. You may know that to have a club, a university club, you have to have 10 students. So we're going to create a club associated with the course. We used to have one. We're bringing it back. I'm putting this as part of the application and talking about this particular group of students and how they keep me relevant to the world surrounding me. I have to describe why I'm the ideal leader for this thing. So it's a very interesting challenge. And I think it has advantages to everybody to have an applicant like me, even if I rank dead last, even if I'm not successful. But I have a feeling I so let's say when you read what the Kipnis Institute is trying to do, they have 3 main areas. I found ways to be in the global leadership of those 3 areas, plus one other associated area. And so rather than just this having local impact, so the building would be known in the city, in the province, maybe not much beyond that, that this colorful building would be known worldwide for leadership advances and AI and lymphedema and a bunch of other things. Yeah. So anyway, I'll let you know how it goes. I guess you'll probably find out when you ever hear my name pronounced in this sentence that has the word Kipnis in it or not. So yeah. So there, that's what we're talking about on Thursday. And it's not just something completely divorced from the students, because in a sense, without them, I don't have a chance. Because if they sense I'm just this old tired guy with no collaboration with younger people, I think the application will go absolutely nowhere. Yeah, anyway, so that's what we're up to on Thursday. Thank you for producing a
Vote
very
for Kim. We don't get to vote, right?
Just a doubt. Sorry. So like you talked about how AI is like learning from humans, right? So and AI is like advancing from like the thoughts of humans and like from all the data that humans are inputting initially, but they are able to like learn on their own. So one day if an AI like produces an idea that can revolutionize the world, and but it is ultimately the human like the humans I like the thoughts and like the data from the humans, right? But the final product is made by the AI. So who would the credit go to?
That
It's no
depends. I mean,
different than humans. When we create something, it's based on our life experience, which comes with the interaction with other people. We don't recount all the people who we've had interaction with in our entire life and then give them credit for the. No, I mean, people accept that. Yeah.
I think there's a lot of governance challenges that, I mean, imagine a case where let's just spitball a case where um, there's absolutely no human knowledge. Like, it turns out the human knowledge was a dead end. that
Right.
like we used it to create AI, but it turns out that like if you think about the like no, to really solve this problem properly, like let's go faster than light travel or like, warp gates or something. You're like, actually, all of human science was a dead end. Let's unroll this all the way back down to I'm a prebiotic clay and I'm going to rebuild from scratch. And I'm going to like rebuild back up into a knowledge foundation, which was completely divorced from the human knowledge foundation
Everything
that's been
human. Yeah.
all of the species. And that was like pretty awesome. I think we'd all be hard pressed to be like, oh yeah, no, like the humans should be like they should get credit for that. Like, no, like literally roll back to prebiotic clay, like charge patterns on clay. Like, there's no way that you can get credit for that. Now, there's another one which like actually it's starting from an abstraction. Let's not go all the way back to clay, but let's say that there's building like as a scientist, I'm going to cite my peers. I'm going to like look at what my good colleagues from out east or down south or across the ocean or in South America, what they've been doing. I'm going to read their papers and I'm going to cite them directly. And I'm going to make it very well known like I'm building on this thing that they built. There's some things that I build on which are abstractions. This is like the sort of the general community knowledge that we've built on, and it's something that you can't really point to in a citation, and that makes reviewers really upset. But there's a lot, especially in like a clinical setting, it's like there's some like just the vibe, and so if you were to go farther and farther back, you might get to abstractions of human output, which clearly have no direct way of being ascribed to anything. Like either it's been lost in the mists of time, or it is something that's been created in aggregate, or it's some kind of like open collective that people have like all written under the like, hey, students t-test, cool. Like you write under the auspices of a single entity, or an organization has produced it. And now you have a non-human person citing a non-human person because organizations are already non-human people, like companies are. So then that's a separate case where you say, oh, okay, well, I mean, if I was a good thinking system, I would still cite my sources. Even if they're abstractions, I would cite them. But whether ownership is required, I think there's a question like, is it a person or is it a tool? And like Rich Sutton is really good at making a distinction. But like if we're getting to the point where it's like, I as a person deployed this and told everything to it and how it's supposed to operate. Companies do this all the time to their like tech workers, and they're like, cool, who owns the IP at the end of the day? The company does. The person is credited with creating it, but they've assigned it to the company. So in this case, it's sort of the reverse. Like that was like the non-human person getting credit for what the humans were doing. And then now we're thinking the reverse. You might get like, humans taking credit for what the non-human people are doing. But I think we have established models which aren't too far off from what that might look like. And then the question really is like, is this a person interacting with a person with different substrates? Is this a person using like if I'm using a hammer and I create like something in the smithy? I'm not giving credit to I mean, I should. I should be like thanking the hammer with all my lucky stars that it was able to like, properly deliver my hammer blow to the right spot. And like, no, I do thank my hammers regularly, but I'm still probably going to be the one that's responsible if that tool I made breaks while someone's using it. Maybe not even like I get the credit. It's I get the credit. If that breaks, it's me. Like I'm the one accountable and responsible for this. I'm the one whose head's on a pike if it goes wrong. And so I think that's also the case for like humans using AI tools or humans working. Who's getting sued? I remember earlier on we were talking a little bit about like when you were introducing your interest areas and like if it's medical malpractice, like who's getting sued? And this is I think right on brand for that, right?
Right.
Yeah, thank you so much.
Cool. Okay, great. Wonderful. And yeah, we look forward to next term. Patrick, I can imagine something even better. Yes. Okay.
I'll try to make something different next term. Sorry to everyone who's not here next term. It'll be something new and maybe worse. Don't worry.
Cool. Okay, great. Thank you very, very
Hi,
much.
everyone. Thank you so much for your time today. I really enjoyed
See
talking
you
with all of you.
Thursday, guys. Bye-bye. Yeah.
Thank you.